Hello, Mr. Malo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on z-scores and normal distributions. So if you find this video helpful or useful, hit like and consider subscribing. So, consider this scenario. It's the day when you finally get your standardized test scores back. And I know some of you have done this before, whether it's ACT, SAT, AP test, PSAT, whatever you want. And in one household, two brothers each took a different AP exam in this scenario. Sibling 1 scored a 3 on the Physics 1 exam, and the mean score for the Physics 1 exam was 2.51 with a standard deviation of 1.24. Sibling 2 scored a 4 on the BC Calc exam, where the mean score of that exam was 3.8 with a standard deviation of 1.27. The two siblings ended in an argument, each claiming that they did the best on their respective exams. And we want to know which sibling is correct in thinking that they did better. Now, most people would just say the score that's highest is the best. And while yes, a higher score is better, you need to think about questions relatively in comparison. They took different tests. People did score differently on each of these. So maybe a 4 on the BC Calc exam isn't as good of a score for that test in comparison to a 3 on the Physics 1 exam. So this is where we can bring in the notion of a z-score. Now, a z-score is the number of standard deviations above or below the mean. So, to settle these siblings' argument, we want to figure out what are the z-scores for their exams. How far above or below the means did they score? Now, z-score, when I say above and below, we're going to let the sign of the z-score dictate that to us. So we're going to set this up so a negative z-score is going to be something that's less than the mean, and a positive z-score is going to be something bigger than the mean. So let's set this up. We're going to use the formula z is equal to value minus mean over standard deviation. So this way, if the value is bigger than the mean, we're going to make sure we have a positive number. And if it's less than the mean, we're going to make sure it's less than the number. So let's calculate the z-score for sibling 1. So I'm going to put a little subscript of 1 there. Now the student took our AP Physics exam. So when we do this, we are going to take their value of a 3, subtract off the mean of 2.51, and divide by the standard deviation of 1.24. And if you plug this into your calculator, we are going to come out with approximately 0.395. So about 0.395. And the way we can interpret this value is that sibling 1 scored 0.395 standard deviations above the mean score of 2.51 on the AP Physics 1 exam. So when you write an interpretation like this, you need to make sure you're including the amount of standard deviations. Since it was positive, that means we were using that word above. So above means positive. And we have context here as well. We're talking about the score on the AP Physics 1 exam. So we have all three of these aspects in our explanation of what it means. So now let's do the same thing for sibling 2. So again, we are going to calculate z-score for sibling 2. They scored a 4 on this BC Calc exam, which had a mean of 3.8 and a standard deviation of 1.27. So you can plug this into your calculator to get that sibling 2 z-score is approximately 0.157. So what that means in the context of our problem is that sibling 2 scored 0.157 standard deviations above the mean score of 3.8 on the BC Calc exam. So again, our z-score represents how many standard deviations you are away from the mean. So in this case, again, it's positive, so it's above the mean. And we got some context. We're talking about this on the BC Calc exam. So when we compare these z-scores, we see that the z-score for sibling 1 is greater than the z-score for sibling 2. And what that means for us is, since z1 is bigger than z2, then comparatively, sibling 1 did better on their exam. So even though sibling 2 did have the higher score, comparatively, sibling 1 did better. So it's not as clear-cut as an answer when you think about comparatively, because these are two different exams. Their grading scales are slightly different. So compared to how other people did, sibling 1 did pretty good. So the takeaways we should have from here when we talk about z-score is z-scores is a measure of how far off a value is from the mean, and this distance is being measured in terms of standard deviations. Additionally, we can calculate the z-score using the formula value minus mean, all divided by standard deviation. So this is going to standardize all our values. A positive z-score is going to indicate a value that is higher than the mean. A negative z-score is going to indicate a value that is lower than the mean. And if you have a z-score that is 0, that means that it is exactly equal to the mean. And you can really see all those in our formulas. If value is equal to mean, the numerator is 0, we get a z-score of 0. If value is greater than the mean, the numerator is negative, so we'll end up with if value is greater than the mean, the numerator is positive, so you'll end up with a positive z-score. And if the value is less than the mean, you'll end up with a negative value in your numerator, meaning that your z-score will turn out to be negative. So I hope this video on z-scores helps you, and hit the like button if it did, and have an awesome day.